Good afternoon, everyone. Moving ahead with our session, it gives me great pleasure to introduce Dr. Rajesh Kumar Arora sir. Dr. Rajesh sir obtained the BTech and Masters of Engineering degrees in Electrical Engineering from Delhi College of Engineering, University of Delhi, India in 1999 and 2003 respectively. He completed his PhD in Grounding System Design from UPES, Dehradun. He is also certified energy manager and auditor. He has worked in 400 kV and 220 kV substation for more than 14 years in Delhi Transco Limited. He has also worked as Deputy Director in Delhi Electricity Regulatory Commission DERC. He has also rendered his services in the SLDC of Delhi Transco Limited also. Presently, he is working in the Design and Engineering Department of DTL as Senior Manager. His research interests include high voltage technology, grounding system design of power system, protection system, computer application in power system, power transmission and distribution designing, regulatory business and affair, etc. Now, I would like to call Dr. VSKV Harish sir to present a bouquet to sir as a token of our appreciation.
Good afternoon. I am here to talk about overview of system, overview of power systems, and the most important topics, the topic of protections and safety. I am here because I am on a mission to make India free of electrical and fire accidents because of failure of assets, fire, electrocutions happening every day without fail. I am here because we are losing 40 precious life in a day, 15,000 in a year, and 75,000 lives of person associated with this 15,000 people shatters. The dreams of many people shatters. There is a loss of precious life. There is a loss of hope. There is a loss of assets already in place. I am here because the people are not ready to implement the proper design. They are not ready to follow the rules and regulations already in place. I am here because I understand the importance of AI. The meaning of AI is not artificial intelligence. I am here because I believe in AI academia and the industry interaction. That is very important. I am here because I am on a mission to make India free of electrical and fire accidents. And journey of 1,000 miles always starts with a single step that I have taken. And the first step in every successful life is the hardest step, and that successful destination always rooted through the commitment you have. I am here to make you understand how to implement proper design, how to do something for the nation you are living in. It is the right time to give back to the society, and as an academia, you have that power to give back to the society because you are nurturing the future of India. You are giving proper education, proper guidance. If you can cultivate proper knowledge, we can do something different. And I need support of everyone sitting here who are connected online. It's matter of India, it's matter of our nation. We have to work together. It's a general overview. I know all of you already understand the importance of power system, and you already understood the components associated with the power systems. It starts with the generation, then sub-transmission, transmission, distribution, and finally coming to your house. The most important thing in that aspect is you have to understand what is renewable and non-renewable energy resources we have available with us. We have wind, hydropower, solar, geothermal biomass that comes in first category, and for the second category the coal, nuclear, natural gas, oil is there. But we have to understand the importance of growth of the power sectors of India. This is a real story. In 1947, total installed capacity was 1.36 gigawatt. Per capita was 16.3 unit kilowatt hour per capita consumption. And inter-regional capacity, that is very important point to note here. There was no inter-regional capacity available. All regions in India were working in isolation. Very important point to note. If you look at the present scenario of today, it is 474 gigawatt, 1255 kilowatt hour per capita consumption, and inter-regional capacity has gone to 118 gigawatt as on 31st March 2024. And we have to move forward 2030. This is how one grid, one nation came into the picture. There were 5 regions, and finally we could achieve that dream in December 2013, when we could synchronize all the different regions and one nation, one frequency dream came true. And important point to mention here that as of March 31st, 2025, that inter-regional capacity has touched 118 gigawatt. That shows within regions we have sufficient transfer capability of power from one region to another region. Conventional versus the modern grid. If you look at the time 25 years ago, this was the scenario. You had one generating station, centralized, you have only transmission line tower, and finally in the radial way it is coming to your house. Now the scenario has totally changed. It has occupied with that distributed energy generation, battery storage. Consumer is not consumer, they have become consumer right now. Conventional protection system have been replaced by smart systems you have. When I say smart, the smart means when you can measure something. When you can measure, you can easily monitor it. When you can monitor it, you have capability to convert that data of measurement into digital. When you can convert it, you can communicate. When you can communicate, you can make all the stakeholders aware, and you can take action required. When you can take action, you can avoid many problems. You can avoid failure of assets, you can avoid fire, you can avoid assets damage. That is the actual meaning of smart system we are working with. This is the architecture of smart substation, smart grid, but actually the smart system I have explained. If you talk about the total energy landscape of present scenario in India, it is a mix of renewable and non-renewable resources. And my country is the third largest consumers of energy globally, with a growing demand driven by population, economic growth. Understanding this landscape is vital for the effective policy making. The most important sheet I prepared, and I keep on preparing without fail every month through the data available on the sites of CA. You have to understand the regions in the Indian systems: northern regions, western regions, southern regions, eastern regions, northeastern regions, islands, and total capacity. If you look at the data of April 2020-25, we have total installed capacity of 472 gigawatt. The contribution of renewable is 37.19. Hydro give their contribution of 10.14%. Nuclear contribution is around 2%. Still we are depending on thermal that contribute 50.81. If you talk about the percentage of small hydro within a renewable section, that contribute 2.9%, wind contribute around 30%, biosolar contributes 7%, and the solar contribution is 61%. If you look at the same renewable energy with respect to total installed capacity, small hydro contribution is 1.08 of the total installed capacity of India. Wind contribute around 11%, and biopower around 2.5%, and solar contribute 23%. This picture depicts many things about the landscape of energy mix in India, and you can also do the same thing by going through the sites of CA. They update all this data every month. You can go there and download the required data and do the proper analysis as per the requirement. Then comes a very important thing, that is the COP26 commitment, Panch Amrit, announced by Honorable Prime Minister of India, Narendra Modi ji. It says the commitment of India is that we have to achieve net zero by 2070. We have to reduce total projected carbon emission by 1 billion tons starting now till 2030. We have to do increasing renewable energy components to 50% of the total energy requirement by 2030, reducing carbon intensity by 45% by 2030, and increasing non-fossil energy capacity to reach 500 gigawatt by 2030. When some commitments are there, to fulfill the commitment, you have to work in that direction. How that journey started to make that dream come true with that PM Surya Ghar Yojana that came in 2020-24, and because of that the consumer is not consumer, it has become consumer. And the microgrid, that is the topics of today's presentation, starts from here. Microgrid are localized energy system that can operate independently or in conjunction with the traditional grid, enhancing energy reliance, resilience and security. These are a crucial role, they play a crucial role in integrating renewable energy sources, promoting sustainability and improving energy reliability in the local communities. And consumers are prosumers now. They are small generators. Their roles have shifted. There is a paradigm shift from consumer itself to the producing electricity also. When the consumer come in the picture, there should be some regulation to take care of that generations of electricity, that is called distributed energy resources. That was governed by that regulation that came in 2013 with first amendment in 2019. The name of that act is Central Electricity Technical Standard for Connectivity of Distributed Generation Resources Regulation 2013. This is the regulation that gives guideline how to maintain, how to go with that distributed energy resources in India. And that first amendment came in 2019. What it says, that regulations give you guidance about the safety. It gives you guidance about the grounding systems you have to maintain. It gives you guidance about metering. It gives you guidance about measurement of the harmonics. It also talk about reactive power compensation. The important aspects with distributed energy resources is the reactive power compensation, because when you are generating electricity in isolation, you need inverter. When inverters are there, they are using some electronics parts, and because of that electronics parts, two problems are there: creation of harmonics and reactive power support. You have to ensure that the inverter you are using give proper reactive power support. In the absence of that, what is going to happen? Anyone from you can explain me? Suppose your inverter of solar PV is not giving support for the reactive power, what is going to happen that after that? Can you give me some practical example? Can you explain? Suppose you have installed one solar PV at your home. Your load was 10 kilowatt, and now you have installed 5 kilowatt solar PV at your home. What is going to happen with that? Any idea? Any idea sitting here? Any idea, sir?
Voltage will increase. If you put the more active power, the voltage at the common point is going to increase.
I can explain what is going to happen after that. What happens to run your load? You need two power. One is your active power, and second is the reactive power. You have installed solar PV of 5 kilowatt. That means the active power requirement from distribution transformer where I was getting the power has reduced by 50%. In case your inverter fails to support reactive power requirement, that will still be coming from the DT you are connected with. When DT produce reactive power more, it causes heating. There will be more losses in the system. Apart from that, as a consumer, my power factor will deteriorate. For the same load, I will be drawing more current and will be paying more. That is ensured by regulation. Your inverter, whatever you choose, should have capability to give you reactive power support also. That is the first important aspect so far safety is concerned. Then what further it guides? It guides you about the protection you need. It says you must have over and under voltage protection. It must have frequency, under frequency and over frequency protection. It must have a function that is most important function, anti-islanding protection. Any one of you can explain what is anti-islanding protections of inverters for solar PV? If it is not there, what is going to happen? Anyone sitting here can explain that features required? Let me explain. Apart from that, it talks about what is the requirement of circuit breaker. It talks about what are the switch gears you need to make your system safe and sound. Apart from that, regulations of CA, the important regulation chapter 10, CA Safety Regulation 2023, emphasis on safety requirements for microgrids we are talking about. We have to go through that chapter. Apart from that, National Electricity Code 2023, chapter part 8 is purely dedicated for solar PV power system safety and requirement. Apart from doing simulation that you are doing as academia, kindly go through the rules and regulations, because finally you have to make system safe, and at ground level you can ensure safety of the systems you have if you understand the rules and regulation already in place. I appreciate the simulation you do. I appreciate the lecture I have seen doing practical simulation on MATLAB. It is equally important to go through the rules and regulations. That is mandatory for the proper implementations of the microgrids we are talking about for last 4 days. Coming back to the very important fundamental things. When we talk about power system revolve around only 3 important parameters. I am repeating, only 3 parameters: voltage, current and frequency. When I say voltage, you have to take care of the system voltage, you have to take care of the over voltage, you have to take care of transient voltages, you have to take care of the lightning voltages, and you have to provide the proper clearances, insulations for the very first part of voltage. Then come current. When I say current, you should have sufficient capacity of conductors to take care of your regular requirement, overloading requirement and a short circuit requirement. And third important aspect, frequency. You have to control the frequency within the given bandwidth as per the regulation. You have to take care of the harmonics being created because of the electronics gadgets in your systems. You have to provide sufficient filters to filter out the harmonics being created in your system. That ensures actual safety at ground level. What are the main dangerous voltages you come across when you become producers of electricity, you become consumer? And if you are not looking at these 6 dangerous scenarios and not providing sufficient design, if you are not taking care of these 6 dangerous voltages, it is going to create problem. In that category, the very first dangerous voltage is the step voltage. Then come the mesh voltage, touch potential, GPR, transfer potential. If you don't have fundamental knowledge about the potential you are going to come across, and you are not paying full attention while designing your systems, because of voltage, there will be electrocution, there will be failure of assets, there will be fire that you can't stop. Now in your system you have 2 choices available with you. Either you will go with the grounding systems or ungrounded system. You have 2 choices with you, grounded system or ungrounded systems. Next. When I say grounded systems, again there are 2 components comes in the picture. Equipment grounding and the system grounding. Equipment grounding to take care of the equipments and the persons who are going to touch your equipments during the fault. And system grounding to fix the voltage with respect to earth, to do the proper insulation coordination, to choose the proper insulation requirement. System earthing plays vital role. Next. The most important thing when I say earthing and grounding, it plays 5 vital functions of every space of power system you go. Be it a microgrid, be it a big grid, be it a generating station, be it a small industry, be it your industry. You can't neglect the role being played by the earthing at all. If you don't understand the role being played by earthing and the grounding, you are missing something. You are neglecting a big thing in your life. Because it is said that in the absence of earth, the system becomes unearthed, and unearthed is a disaster. That earthing provides a return path for that fault current back to the source. It provides safety of living beings around the vicinity of substations and the systems you are working with. It ensures the proper functioning of your protective relays, and it limits the touch potential and the step potential. And last but not the least, it takes care of the lightning discharges that may attack or strike on your structures. Apart from earthing and grounding, I have talked about the bonding plays a vital role. The bondings even in your life plays a vital role. In the similar fashion, if you are not providing proper bonding so the equipment within the system, if you don't understand that concept, you are not doing the proper justice with your equipments you are using. You have to ensure proper grounding, you have to ensure the proper bonding of the equipments you are using in your system. To understand that thing, you can refer that figure, why that grounding is important. In the absence of dedicated path for that fault current to back to the source, go back. Suppose this is your source, this is your actual system where that fault happens. When it happens, that is called SLG fault, single line to ground fault. It has one choice, to go back to the source through that Mother Earth. When it is going back through Mother Earth, let's say the resistivity offered is 10 ohm meter in the very good condition, it will take time to back to the source. If you provide a proper dedicated earth from this point to this point, it will provide 1 crore times least resistance. I can give you example. If you look at, suppose you provide one aluminum wire, the resistivity of aluminum is 2.54 10 raised to power minus 8 ohm meter, and for your Mother Earth is 10 raised to ohm meter. If you compare it, there is a difference of around 1 crore times. Dedicated earth always ensure the safety. It helps that sensitive relays to operate in the minimum time. That finally decides the time period of isolation and helps to reduce electrocution and failure and fires. Very important picture to understand. What happens when you come across any ambulance on the road? What is your duty after that? To give way to that ambulance to reach to the hospital, because you understand the importance of precious life inside the ambulance. But go back. But what about that costly equipments and the livestock and the personal working in your system? At the time of fault, if you don't provide that dedicated path for that fault current to reach to the source, that equipments, that persons will lose their life. Never ignore the importance of earthing and grounding. You have to give full attention to ensure safety, and you have to ensure that all the equipments are in proper healthy condition. Next. What happens when a fault happens? When fault happens in any system, there is another important factor comes in the picture, that is called earth surface potential. And because of that earth surface potential, when you touch any metallic part, there is a potential difference between the metallic part you are touching and the point where you are standing. There will be some potential difference, and because of that, whenever you touch any metallic part, especially in the rainy seasons, the persons get electrocuted. And recently, 2 days back, I was going through the newspaper and there was news of 9-year-old one child got electrocuted in the park while playing in the ground. Why it is happening every day? Because we don't provide the required earthing and grounding. We don't provide the required RCD. We don't look at the regulation already in place. We don't provide proper bonding. We don't look at the step and the touch potential we come across. Next. When you don't provide that thing, one thing is bound to happen, that is accident because of the step potential and accident because of the touch potential depicted by that picture. How to do that thing? This was about the system fault. What about the lightning you come across? That pictures tells 1000 words about the working principle of lightning protection you provide for the buildings you have. When I say lightning, you must go through the IEC 62305 part 1, part 2, part 3, part 4. And accordingly you have to design what are the safety required for the building you are working with or living in. And finally to be connected to earth. Next. That was the general safety. Now coming to the safety associated with the microgrids and how to ensure that microgrids remains safe, sound, and ensure that the persons working in that vicinity are safe. These are the general arrangement of my solar PV. It has some cell, then comes a module, then modules are connected to make a string, and strings are connected to make an array. Next. And for buildings, this is actual picture it looked like. Next. Then the on-grid system. In on-grid systems, you have inverter, you have that net metering systems, finally it is connected to grid. Next. This is about the off-grid. In off-grid system, it is not connected to your utility, it is used within your premises. Next. This is a hybrid system, and this is about the metering system. Next. These are typical SLD I have taken from actual project, that is for that particular site. This is how these systems are connected. Now important part for the solar PV is that how many earthings are required and how these earthings to be connected to your PV system. Any idea how many earthings are required for solar PV and why? Anyone? Okay. The important part is that for the solar PV at the rooftop, one important aspect is the lightning protection. Then if you look at that here, inverter, this is my array strings, combiner box. Then on inverter DC side is there, and on the second side AC side is there, then DC DB, AC DB, then your system, and through metering it is going to system. And at the top you need one earthing for all this frame structure, you need one earthing for the lightning protection, and you need another earthing for this inverter. And all these system must be interconnected together. Next one. And the most important successful story is community based microgrids. When I say community based microgrids, means in a society As a society member, you can install a big size of microgrids for the entire society. Industrial microgrid solutions are there. When you are providing that solar system for use within the industries you are working with. Next. And important aspects with respect to that solar PV, the standard testing condition. Whatever you get, data you get at the rating plate of your solar system, that is based on the standard testing condition. That means spectrum of air mass 1.5 at 100 watt per square meter perpendicularly incident on a PV module, wherein the PV module temperature is fixed at 25 degree. If some changes happen, accordingly there will be variation in the efficiency declared by the vendors. You have to keep in mind that thing. Next. That is most important thing, islanding schemes. Suppose this is my system. This is my solar PV. It is connected to my inverter and it is connected after net metering to my utility. Understand that, suppose imagine a situation when there is a problem in the utility. In that case, that power is not here. That system becomes islanded and it will be supplying within house in a islanding mode. But as per regulation I have mentioned in the beginning, that conditions is not allowed. Next one, that is called anti-islanding protection system. That is very important thing for the safety. Can anyone explain? Go back to the slide. If that situation happens and I start taking load, what is going to happen? Why that is not allowed? Any one of you can explain? There is a problem in the network. Still you are generating power. What is the consequences of that thing? And why it is not allowed as per the regulation in India, in world? What happens if you do generation in the islanding mode? That power may go back to the utility system and the persons who are doing the maintenance may get a shock. That feature is mandatory for the inverters you are purchasing. That is called anti-islanding protection system of solar.
Could you please again? It's not clear. Anti-islanding means just
That means islanding is not allowed.
Islanding is not allowed.
Not allowed.
Islanding is not allowed, but then you are generating in the solar end, no?
No, it will stop automatically.
But it will stop.
Yeah, and it senses through two parameters, primarily frequency and the voltage.
So the grid frequency and voltage is not there, it should stop.
It will stop, definitely.
That is the thing, eh?
Yeah, that is called anti-islanding protection.
The solar cannot generate at all.
No, it will stop generating for that particular period. Synchronization will fail. Next. Apart from that, two another protection systems are there in a solar PV. Bypass and the blocking diodes. Bypass to take care of the shading effects in the module, and blocking diode to ensure that in no case the reverse power flow reverse back to the solar PV at all. Next. Then comes the grounding and earthing. To understand grounding and earthing, you have to understand that picture first. This is my solar PV. This is GEC. GEC means grounding electrode conductor, and EGC means equipment grounding conductor. Here, look at here. this one. This is option number 1 to ensure the safety, to do the earthing and grounding systems. Option number 2, next one. What you do, you take GEC from the inverter itself. Grounding electrode connector you are taking from this one. There is no separate electrode system for both. Third, this is a combined system where only one electrode is required. But in Indian system, it is mandatory as per the government MNRC guidelines to have 3 electrodes. One is for your lighting, one is for your equipment, one is for inverter systems.
So we have to connect all of them.
Yeah, I am coming to that one. Next. This is how that lightning protections are to be protected. Next one. This is actual picture. Next. This is how that, for the solar farm, how that lightning protections are provided based on the calculation design. Next. Then comes next one. SPD, surge protection devices. We have talked about lightning. Lightning may strike on your building. It may damage your solar PV. And finally your solar PV is connected to your load inside the building. That lightning comes for microseconds, for a very short duration, and SPD helps you to save the equipments you are using in the building, and that is to be provided on the AC side and the DC side. Next one. And when I say SPD, it is of 3 types: type 1, type 2 and type 3. When I say type 1, type 2, type 3, next one. This is how that SPD helps you to protect your equipments you are using in your system. At the time of fault, that works on the principle of equipotential. For that particular duration, SPD will create equipotential between the gadgets and the earth. There won't be any rise in the voltage. When there is no rise in the voltage, your system will remain intact. There won't be failure of any electronics gadgets in the building you are living in. This is the beauty of the SPD. Next. This is the typical methods, and you have to design. Next one. This is the typical earthing designing of your solar PV. Next one. When equipment grounding in DC systems, suppose you are using BESS, how to do grounding is depicted by here in this picture. Equipment grounding, charge controller, this is your batteries, and batteries coming to breaker, and this is how you have to provide a grounding. Next. And this is how the lightning protections are provided based on the calculation and design. Next one. This is the NEC guidelines that gives guidance in the clause number 7.1, page 732 of NEC 2023. What are the, how to do the proper earthing? That DC side, it talks about the DC side. Next one. This picture depicts everything. You can refer that NEC 2023 to ensure how that earthing is to be done. These 4 figures are very important. Next one. This is typical earthing bonding in the PV systems. It is again from the NEC. I have already mentioned about it. Next one. And when you talk about specification, these are typical specification of solar PV. It talks about output, it talks about short circuit, it talks about open circuit voltage, maximum current, power, and all these conditions are on, STC, standard testing condition. Next. And if you look at the bill of quantity, there is one solar inverter is there, there is solar battery is there are some module mounting stands are there. This comes along with the solar systems you are working with. Next. There will be DC wires, AC wire, DC DB, AC DB. Next. There connectors, lightning arrestor, earthing kit to be provided. Next one. These are typical features of inverters. Next. And these are the safety features I have already mentioned. There will be anti-lightning protection, support should be there, overcurrent protection should be there, short circuit protection should be there, DC reverse power protection should be there, surge arrestor, isolation detection support, and leakage current protection should be there. If you can ensure all these things, you can ensure the safety for your system. And this is a 9C principle of any systems, any microgrids, major grids you are working with. That shows there should be proper correct design. And after proper design, that must be proper connected. That is called ETC, erection, testings and commissioning. Then comes proper connection to your earth. Then comes proper clearances. Then comes proper heat dissipation of the equipments. Then IP protection, ingress protection. That ensures that the equipments, the gadgets, the inverters, the systems, the panels you are using can withstand with the dust, water, and that IP code ensures that thing. Then comes proper insulation coordination, proper protection, proper condition monitoring, and proper maintenance. And there are 7 golden rules of the safety wherever you are working. It starts with HERA. You have to identify hazard, then you have to do the risk assessment of that site. You have to clearly ensure that the work location equipments where the maintenance work to be carried out, you have to pinpoint that location. You have to ask for the permit to work. Then you have to apply LOTO. Then you have to ensure that there is absence of operating voltages before starting of any work. You have to do the proper grounding, and you have to ensure that there is no adjacent live part. Last but not the least, you have to use the proper protective equipments before starting off any work in the system. Safety first, safety last, and safety always. Safety is a mindset, safety is a culture, safety is a responsibility. We have to provide zero harm culture to make India free of electrical and fire accidents. And together we can. When I say together, we have to use IA, AI, academia and industry collaboration definitely can make India a safe country to live in, free of electrical and fire accident and assets failure. We have to understand the importance of earthing and grounding. We have to ensure that all the rules and regulations already in place are implemented. in letter and spirit. We have to ensure that we give full attention to the safety rules and regulations. Next. And we have to go through all these courses apart from doing simulation that you are doing at academia level, that talks about the regulations and law requirement related to the microgrids you come across. Next. In future, I have mentioned about AI and machine learning is going to help me in the future. Advanced meeting infrastructure definitely help me to make my system more advanced. Next. And finally, this is not the end. This is a new beginning for the participant sitting here and the online participant.
Thank you so much, sir, for providing an insight on the safety rules and the regulations along with the protection type that we should always keep in mind. Thank you so much. Now I would like to request Dr. Ravinder Singh sir to present a token of gratitude to sir. So now we have a validatory session that is going to be start after 10-minute break. Thank you so much. Good afternoon everyone. I am Savita, University Research Fellow of Electrical Engineering Department, and I feel truly honored to welcome you all to the validatory ceremony of RE Connect 2025 organized by the Department of Electrical Engineering at NSUT. Before moving further, I would like to share a quick recap of the enriching experience we have had throughout RE Connect 2025. Over the course of this week, we have had the privilege of hearing from most distinguished experts from both academics as well as industries in the field of electrical and renewable energy system. The hands-on session gave participants the opportunity to engage themselves with real-world tools, simulation, and practical demonstrations. The sessions covered a wide range of topics from smart grid technologies and renewable energy integration to energy storage, power electronics, and many more. Indeed, it has been a week full of learning, collaboration, and inspiration. Now, let us take a moment to express our gratitude through a small but profound felicitation ceremony. First, I request Professor Smriti Madam to kindly present a flower bouquet and a token of appreciation to our guest of honor, Professor A.K. Dubey sir. Now I request her to felicitate our special guest, Dr. Rajesh sir, with the same gesture. Finally, I request Dr. Ravinder Singh sir to please felicitate Professor Smriti Srivastav ma'am. Thank you to all our guests for accepting our humble tokens of appreciation. To invite Professor Smriti ma'am to share her valuable insight with us.
So the last day has come. So I think the participants from the outside NSUT, they must have benefited a lot. So I congratulate you that you have completed this course, which was full of information and knowledge. And I think we got some external industry professionals as well as in-house speakers. So you must have benefited. I think one of you or two of you should come here and share the experience with us. That would be great. So I request one or two of the external participants to share some insights, whatever they have gained in this 5-day program. Please. And thank you very much for coming and joining this session every day.
Good afternoon. I think good evening now. Good evening everyone. My name is Arvind Gupta. and I have been from industry, and then I have recently moved to academia. I mean, I am taking independent teaching at industries and academia and institutions. So I am coming to NSUT after around 5 years. I was also here 2019. I had also taught here as a visiting faculty in control systems, and then now I am at Delhi Technical University. I am teaching courses to BTech students and also to industries. So because I have had a journey, I think I did. I had told my name, Arvind Gupta. I think I did tell. So I actually my journey was in 1989. I passed my BTech from Warangal, and then I did my MEMTech from IIT Delhi. Thereafter, I was into industry, and I was into academia. So I taught for around 4 years at Kurukshetra and Chandigarh, and later on I moved to BHEL 15 years. Thereafter, again I went to private industries. So I have a very good idea of the academia as an industry in India. So I thought that many of the students, I mean, they are not very clear about what to do, and they're always confused about, like I was also once upon a time. So I do a lot of mentoring now. So telling them then what is the right thing for them. And many people are not getting into the core electrical engineering, core subjects. They're getting driven by many things, many very good students also. So I just tell them that you have to be patient and try to do that. Coming to this workshop, I think it has been very good that I have come to know many new things. And I always love to listen to youngsters like your professors who have called me, and particularly Harishji sent me a LinkedIn message that, sir, please come, and then I just joined. I was at Gujarat, I was giving some workshop. So he said that, then I said that yes, I'll be back. But 2 days I had to miss because of certain problems in my college. But anyway, 3 days I have attended, and I must say that we have, though we may not have a very large audience, we may not have a large participant, but whatever you have done is very good. And I think we must continue to do these things. I am very much enriched personally, and I think we must encourage ourselves. And Mr. Rajesh ji ka I was mind-boggling. His presentation was mind-boggling because earthing has been a problem in power plants. I have seen that so many electrocutions have taken place, and I will also narrate my problems of so much electrocution in my entire life. And I am so afraid that nobody knows in the industry. The big stalwarts, they're doing big things, we are doing things, but earthing ke mamle mein, we are all so, and many people know him. I have particularly told Mr. Rajesh is coming. Kindly meet him, get his number, and we want to talk, because all people who are retired also, they are stuck up with industry, because earthing is a very peculiar subject. It's not very well known, it's modeling and all that. So I think it has been a very good thing that we will always benefit. It could be a smaller thing, but it is always benefit, and I am trying to encourage my own industry friends. I have a lot of things, but people generally feel very difficult to send somebody for 5 days. But I think people should do that, because once they start coming, so this has been my practice, because when I was a youngster, I was always coming. It may be, it has to be something from inside. Curiosity should be there. So you may not initially understand everything, but still let us start with that. So I think I must stop with this, madam. Thank you very much for this opportunity.
Thank you, ma'am. Now, I am honored to invite our special guest of the ceremony, Dr. Rajesh sir from DTL, to give us his valuable viewpoints.
Good evening. I always start my speech with thanks to Almighty, my family members, my mentors, my well-wishers, because whatever I am doing, whatever I have achieved, only because of their good wishes and blessings. It is quite important for a person to give back to the society. It is your duty. Whatever you have learnt in any way, in any form, you should give back to the society, because there are two things in your life: race and the grace. The only difference is the G, and that race becomes grace when you take help of your mentors. Your life becomes totally different, and in your journey, the very first step is the hardest step always. Take that step and automatically a thing will change. Never stop learning, because your life never stop teaching you. Give your 100% and always try to decide what you want to do. Take determination and finally go and do it. I am on a mission to make India free of electrical and fire and assets failure. I have taken that step of 1,000-mile journey with a step I have taken to form a small group of igniting power engineers. I start my day with one videos of safety and I end my day with one videos of safety. And I believe in BMW. I always say to Almighty, bless my work, bring me wisdom and burn all my worries.
No, all BMW.
Like others, I also need BMW but of different type. And I always say to my students, never waste your tea. Who never give you appreciation, who never admire your work, and that tea is the time, energy and attention. And spend time for yourself. You are the biggest assets of your life. Keep doing good things, keep learning, keep improvising and make India proud. Thank you very much. Thanks a lot.
I cordially invite Dean FEME Professor A.K. Dubey sir, our guest of honor, to address the participant and share his expert thoughts.
Thank you, and it was really I'm delighted to hear from the participants beautiful, satisfying words from them about how the workshop progressed over the period. Some word of wisdom from one of the participants, Dr. Rajesh.
Yes.
He is participant as well as speaker.
Participant is speaker, motivator. He seems more like a motivator.
Yes.
So I think this is also a task to be carried forward by one of us, and he is the one who has taken the liability and the responsibility of making safety as the core of whatever electrical engineering you people are doing. So I'm sure that most of the participants would have benefited from the proceedings of this conference, from the activities of this conference, and hope that you take this learning back home and make use of it, apply in your teaching, learning and professional work. And as he said that Dr. Rajesh has said, giving back whatever you learn is a very important component of the professional and personal growth. So with these words, I again congratulate you and thank you for being here, and my best wishes. Hope you have taken this opportunity in good stride and be benefited with this. Thank you.
Thank you, sir. Now I invite Dr. Ravinder Sir to present the vote of thanks.
Thank you, Savita. Okay. A very good afternoon to all. It is truly my honor to deliver the vote of thanks for the validatory function RE Connect 2025. The past week has been a remarkable journey showcasing our collective dedication innovation in renewable energy. We are grateful for the immense support and guidance that underpin the short-term course, that is renewable energy control and network integration for smart grid. We particularly want to acknowledge the outstanding leadership of our Honorable Vice Chancellor, Professor Anand Shrivastava, whose commitment to the promoting such crucial initiative is truly commendable. A special thanks goes to the esteemed patron, Professor A.K. Dubey, Dean FEME, and our distinguished guest of the event. We extend our sincere gratitude to Dr. Rajesh Arora, Senior Manager, Delhi Transco Limited, our special guest. To Professor Simriti Srivastava, Head Electrical Engineering, our Principal Coordinator, thank you for the exceptional vision and tireless effort in making Reconnect such a resounding success. My heartfelt appreciation also goes to the expert team who structured this comprehensive course, our course convener, Dr. VSKV Harish, Dr. Astithav Kumar, Dr. Ravinder Singh, and the course coordinators, Dr. Ankit Kumar Singh, Dr. Shubhadeep Saha, Dr. Anjani Kumar Mishra. Your careful planning and execution ensured a smooth, informative, and truly enriching experience for all the participants. A special mention thanks to our dedicated student volunteer, Savita, Shweta, and Pushparaj. We also express our deepest gratitude to all the staff members who work tirelessly behind the scene. Finally, the most important, a huge thanks to our dedicated participant of the RE Connect 2025. Your active engagement and insightful questions have made the course truly interactive and rewarding. Thank you for being a part of the RE Connect 2025.
To mark the conclusion of today's ceremony and to initiate certificate distribution, I would like to call Dr. VSKV Harish sir, convener of the STC course.
Thank you, Savita. I'll just take 1 minute and then we'll start the main proceedings for which we all have been waiting, except high tea. We have had total 79 registrations, out of which 67 were online registrations and 12 were offline registrations in India and in abroad as well. We are, because we have recorded sessions from various places and also the still photography, we are assembling all the presentations of the speakers. They have agreed to share with us their presentations along with MATLAB code and MATLAB model. So we are, and also the supporting papers, research papers which they have. So we are in the process of assembling them, including the photographs and also the videography. And those participants who are getting the offline certificates will also get a scanned copy of the online certification, and all of this will be assembled and provided to all the participants, be it online or offline, within a week. So I request all of you to kindly bear with us. So we'll start with the certificate distribution. I request all the dignitaries to kindly stand, and then we'll have a certificate distribution. Mr. Aman Dahiya from Netaji Subhas University of Technology. Ms. Soumya from IGTTUW. Dr. Monu Malik from Maharaja Surajmal Institute of Technology. Ritambara Katoch, DTU Delhi. Dr. Kapil Chauhan, NIT Allahabad.